Hello, guys. Good evening. This is the fifth part of your data engineering YouTube live series. I've got a massive response for the previous video, and I'm glad about it. So, we are continuing to further parts of this series. So, today will be the fifth video for the same series, the data engineering series. And I welcome you all on behalf of Data Valley. Data Valley is the fastest growing edtech company of 2025, and we offer a variety of courses including data analytics, machine learning, Java developing, Python development, and loads of stuff for you to learn. So do check out on our website, Data Valley. We are a MNC company where we are based out of US, UK, and Hyderabad. So we'll jump to the video today. And myself, Franklin, I've been a data engineer for almost 3+ years, and I'm very glad to bring this video to you. And I feel genuinely happy because it's more or less like a knowledge sharing from my point. So, hope you all sit relaxed, and you all know the routine, right? Grab your coffee, come sit and chill for an hour, listen very focused, and if you have any doubts, please feel free to drop your questions in the comment section, and I will have a follow up on those. And pay attention, and good luck with all your data engineering interviews that you have in the future. All right, so without further talking, let's jump to our agenda for the day. So today we will be covering few of SQL questions, and then we'll be jumping to data modeling, and then the third part will be about the big data tools, and then we'll be covering few questions from ETL pipelines, and then the cloud technologies. So to begin with the first part, SQL. Explain the difference between inner join, left join, and full outer join. So this is our question. I hope you all are aware about joins, right? So join is where you try to match two tables with a common value, right? So there is going to be one common column between two different tables or two and more tables, and you try to match it based on the column values from the both the table, and therefore you create a join. In join, you have varieties like inner join, left join, right join, full outer join, and there are furthermore as well like cross join. We have plenty, but let's not worry about it for now, because now our focus is on the four types of join, which is very commonly used for all your data engineering use cases. So what is an inner join? So inner join, it returns only the matching rows in both the table. So if there is only a match between two tables, only those matches will be queried out. Okay, so that is called as your inner join. So if you see the below diagram, I have a left table and then I have a right table. And when I do an inner join based on a common column between these two tables, I'll be getting only the yellow part that you see here, which is the matching rows between two tables. All right, so this is the inner join. So anything that is matching between two different tables, you get that as a queried out result. And talking about left join, in left join, the left has more weightage. Okay, so that's the simplest way you can remember it. The left table is going to be prioritized more in comparison to the other tables or the right table. Okay, so in this case, you're going to get all the rows from your left table. Why? Because your left table is prioritized. So you're going to get all the rows from your left table, and then only the matching rows from your right table. Okay, so if you see this image below for the left join, there are two tables, left table and right table. And when I run a left join on a common column between two tables, all the rows from the left table, okay, the yellow part is the queried out result. Okay, so I'm getting all the results from my left table, and then the matching tables, the matching fields to the right table. Okay, all the data from the left table and the matching rows from the right table. So this is the left join, and it returns null if there is no match, because as we see here, we're getting all the rows from your left table, right? Let's say in your left table you have 5 rows, and let's put their numbers as 1, 2, 3, 4, and 5. But in your right table there are only two values, that is 1 and 2. And when I say left join, I'm going to get all the rows from my left table. So ultimately I'll be getting 1, 2, 3, 4, 5. And because there is matching row to my right table, I'll be getting 1 and 2. And what will happen to my other three fields for the next three rows, that is number 3, 4, and 5? So because you don't have a match in the right table, you'll be getting it replaced by null values. So that's how your left join works. And talking about right join, in the right join, the right table is prioritized more. So what do I mean by prioritized? So you're going to get all the values from your right table, irrelevant if they have a match or not. So they return all the rows from your right table, and then only the matching rows from the left table. So as you see in the diagram below, you have the right join here. So I have two tables again, a left table and a right table. Because my priority here is right table, because I've used right join. Oh, this image is a bit wrong, but let's consider this to be a right table and this to be left table. Okay, in this case, all my data from my right table, okay, I'll be getting out. Oh no, the image is right, so don't worry. So all my data from my right table, I will get it. Okay, wherever it is shadowed orange, I'll be getting all the results from it. Okay, and then only the matching data to my left table. Okay, let's talk in our previous context. Let's say in my right table I have 1, 2, 3, 4, and 5, and my left table I have 1 and 2. When I run a right join based on a common column between these two tables, I'll be getting 1, 2, 3, 4, and 5 from my right table, because I have done right join. My priority is the right table. So I'll be getting all the data from my right table, but only the matching values from my left table. So that should be 1 and 2. So for the other three values, the 3, 4, and 5, I'll be getting it replaced with null values. So that's how the left join and right join differ to each other. And about the full outer join, you're going to get all rows from our body table. So let's see in this below example, I have a full join here. I'm getting all the data from my left table and all the data from my right table. Okay, so wherever there is a match, okay, it is good. And let's say if there is no matches, okay, let's say you have few columns in here, for instance 1, 2, 3, 4, and 5. And let's say in my right table I have three columns, 1, 2, and 6. So how this table would give a result? So left table you're going to get 1, 2, 3, 4, 5, and right table you're going to get 1, 2, and 6. But because there is a no match for the left table number 3, 4, and 5, it'll be replaced with the null in your right table. And because your left table doesn't have 6 but your right table has 6, the left table is going to give null value for your missing place in relevance to your right table field. Okay, so not just in theory, we are going to see this in a code implementation for your better understanding. So I hope this image is very clear to you. In the inner join you have two tables, left and right. You are getting only the matching columns. In your full outer join you are getting all the matching plus non-matching data from both your left and right table. And for your left join, you're going to get the data, all the rows from your left table and only the matching data from your right table. When talking about the right join, you're going to get all the data from your right table and only the matching rows from your left table. So let's see how this works in our uh, SQL workbench. So here and I've got my MySQL workbench running. So let me empty if I have any database there. Okay. So I'm creating a new database here. So I'm creating a database called data engineering and I want to use that database. So I'm using use data engineering. This is my initial DDL for my customers table. And my customers table is having two columns. Those are customer ID and name. So customer ID is of integer type and name is of text type. Okay. And my next table, orders table, is having three columns: the order ID, customer ID, and order date. The order ID is going to have integer data type, customer ID is going to have integer data type, and order date is going to have date data type. Okay. So let's see how our table looks like. So this is my customers table. I've got two rows, customer ID and name, two columns, and I'm running my orders table as well. So oh, we haven't created it. Okay. So when I run the select query, you can see that I've got my table with three columns: the order ID, customer ID, and order date. Okay. Now what we'll do is we'll try to insert few values into both our tables. Okay. So first, to our customers table, we are inserting few values: one Alice, two Bob, and three Charlie. And to our the other table, the orders table, I'm inserting few values again. So it's going to have order ID, customer ID, and the order date. Let's see how this looks in the table format. So my customers table, as you see here, I've got customer ID 123 and name Alice, Bob, and Charlie. And for my orders table, you can see that I've got three columns with values: order ID 101, 102, 103, and my customer IDs are 1, 2, and 4, and my order dates are 1st of Jan 2024, 5th of Jan 2024, and 5th of Jan 2024. Okay. Based on these two table, I think you would have got an understanding what values are missing. So you have got 1, 2, 3 here, the customer IDs, and in my orders table I missed 3, right? So I have got 1, 2, and the next is value number 4, customer ID, which is absent in our customers table. Okay, let's see how this would result out when we try to implement joins. So first we'll start with the inner join. What I'm doing here, I'm selecting name and order date. Why have I used C dot and O dot? So you can see I've used dot notations here with few aliases like C and O. So what do they correspond to? So what do they correspond? So they correspond to the table names. Okay. So if you see in this, I've got selects and column names from my customers table, which is good. And instead of using the same name over my column selection, so instead of C, I can still use customers dot name, and in here I can put orders dot order date. But what we are doing here is we want to keep the code for better readability. We want to keep the code very simple. So we are using alias here, customers. So we are giving alias C, and for orders table, I'm giving alias O. And the keyword here is inner join. Okay. So select c.name o.order date from customers with alias c and inner join to orders o, which is well and good. And then here is our matching column. So I'm trying to match it with the customer ID from my customers table and customer ID from my orders table. And there is one suggestion based on industry best practice. You always gotta use your table alias name in your column name selection. The reason being, let's say you have same column name in two different tables, okay? And there is going to be an ambiguity. What do I mean by ambiguity? Because there is two column names that are similar, it is going to be tough for your database to determine which one are you trying to look for. So are you trying to look for the customer ID from your customers table or your customer IDs from your order table? So as an industry best practice, I would always recommend try to use table name with a dot notation next to your column names. Okay, so you tag your table name along with your column names. So if I run the inner join here, what do we get? Only the matching rows, right? So the matching rows between two different tables are Alice and Bob. Can you take a guess why? Because if you see in our customers table, we have got Alice, Bob, and Charlie, whose customer ID is 3. But in orders table, we have got only customer ID 1, 2, and 4. So 3 is missing in orders table and 4 is missing in the customers table. So if there should be a match, it should be only 1 and 2. And when I run the inner join, this is how our result has come out. All right, I hope this is very clear to you. And then let's jump to our left join. So in left join, what happens? Your priority is your left table. You get all the rows from your left table and only the matching rows from your right table. And wherever there is not a match, you replace it with null. So I'm selecting the columns, the same columns, customer name and o.order date. And then I'm using alias C for customers and O for orders. And the keyword here is left join. So in the above example, we saw that we are using inner join for our inner join function. And left join is a keyword for your left join. Okay. And here is your matching column. So customer ID from your customers table and customer ID from your orders table. And when I run this left join, only the matching columns from your right table and all the all the rows from your left join come up. So your customers table has Alice, Bob, and Charlie 1, 2, and 3. And because Charlie is absent in your orders table, you're not going to have an order date for Charlie, right? Because Charlie is missing in your orders table. So therefore, you're missing out on the orders date. And therefore, the missing value has been replaced with null as you see below. So this is how your left join works. And to our next type of join, the right join. In the right join, you get the matching values between the left and the right table. And because it is a right join, the priority is going to be a right table. Therefore, you're going to get all the values from your right table and only the matching data to your left table. And wherever there is not a match to your right table, it is going to be replaced with a null from your left table. Okay, so in here, if you see, I'm selecting name from my customers table and order date from my orders table. So from customers, define that I'm taking it from the customers table and I've used alias C. And right join indicates that right table is my priority and my right table is orders in here. And I'm using alias O for this. And the matching columns here are on. So on this matching column, c.customer ID is equal to customer ID from my orders table and a semicolon. So when I try to run this, my right table is going to get the high weightage, right? So before we run, let's see what is in our right table, the orders table, right? So this is how our right table, the orders table looks like. So you're having 124 customer ID, order date, and order ID 101, 102, and 103. And now when I run this right join, you can see that I've got all three values from my orders table. And because the name for the corresponding order date is missing in my left table, it is replaced with null as you see here. Alright, because my right join is given more priority and left join only matches, and wherever there is not a match, you get it replaced with your null values. And talking about full outer join, MySQL doesn't support full outer join. Okay, so what does a full outer join do? It takes all the rows, though it is matching or non-matching, it just takes all the data from both our tables. Okay, because in MySQL full outer join is not supported, we are going to simulate the same functionality using union. Okay, so union is going to simulate as much similar functionality to full outer join. So what I have done here is very simple. The code might seem bigger to you, but if you consider this short, let me try to break it down. See what I've done here. This is my left join, right? This is how I ran my left join, right? And this is my right join. It's the same code, but I've just used the keyword union here. So it's going to simulate more or less the same functionality as a full outer join. And when I run this code, you can see that I've got Alice, Bob, and Charlie from my customers table. Yes, those were already present. And my order date, you can see that I've got only three values. So 1, 2, and the fourth value is for the customer ID 4, which is absent in my customers table, and hence it is replaced with null. And for Charlie, he didn't place any order, so he's not going to have an order date. Hence, then empty space is filled with null. So this is how your joins work in your SQL. So for short, try to remember this image. It's going to give you a better understanding. All right. So to our next question. How would you detect gaps in a sequence of IDs or dates using SQL? So the use case scenario here is you have to understand the gaps in a sequence of IDs or dates using SQL. So the business use case or your requirement in here is, see, I have a data table and there is going to be IDs in sequence. But I want you to find if there are any gaps at all between these IDs. And how are we going to do this? And where are these use cases in place? The use cases include but not limited to, in your business there might be a scenario where you have to find the missing invoice IDs. So that is one of the use case. Let's say you have a timestamp running, the log timestamps. But there are chances that you might have a gaps in your logging timestamps. So for these kind of scenarios, you use these SQL functionalities to detect the gaps. So before we see the code implementation, I will try to explain this code for your better understanding, and then we will see how it is getting implemented in your MySQL workbench. So if you see this code as a whole, it is going to be very complicated, but let's keep this very simple. Okay, we will start little by little. So I'll start with the subquery here. I've got a subquery here. What am I doing here? So what I'm doing here is I've put this as select one from sequence demo. Okay, Assume that sequence demo is your table name. Okay, so select one from sequence demo with alias sd2. I will explain this why I've used sd2 when I come to the outer join, I mean outer query, where sd2 dot id is equal to sequence demo dot id plus 1. So what's happening here? I'm selecting one. So what does one mean? Does that mean that I'm fetching a numerical value like 1? No, it's just a placeholder. Okay, so instead of loading or retrieving all your data from your table, what you're going to do here is you're just going to check for the existence. Okay, so this one will return a constant instead of fetching all your data from your table. Okay, so I've set the placeholder which is going to return me a constant from this table sequence demo, which is our original table, but I'm giving an alias sd2. Okay, where sd2.id is equal to sequence demo.id plus 1. So what's happening here is I'm fetching the id from my sd2 sequence demo table, and I'm checking if it is similar to sequence demo.id plus 1. Okay, so coming to our outer query, which will give you a better understanding, select id plus 1. So what I'm doing here is, see, what happens in this case? You're going to select ID column from your sequence demo table, right? But what I'm doing is, okay, you select the ID, but to that add a number 1, okay, for each of the ID as missing ID from sequence demo. Okay, I'm fetching my ID with 1 added to it from my sequence demo table, and I'm checking into my inner query. Okay, so where not exists. So what's happening here is I'm checking for the existing value. So what is select one going to do? It's going to just return me a constant instead of fetching the actual value, right? So this is going to select me all the ID. And what's happening here, because I'm adding one value on top of my existing value, it is going to compare it with the values that is fetched from this query, hence making sure that where the missing id is. So to put it in a simple word, so let's say uh, your original table. Okay, you're having a sequence here, 1 comma 2 comma 4 comma 5. Let's say this is what your original table is holding up, and now your goal is to find the missing value, I mean find the gap in your sequence. Okay, to explain in context to the above query, so this query is going to fetch me a value. Okay, this is my original table. Okay, 1 2 4 5. So for the first query, so in my outer query, because I'm adding 1 to each, I'm going to get 2 comma 3 comma 5 comma 6. And my inner query, okay, it is just going to check for the existence of all the id, which are 1 comma 2 comma 3 comma, I mean no 3, it's 4 comma 5. All right, so this is a match, right? So I have match 2, I've got a match 2, I've got a match 5, I've got a match 5. But what am I missing here? I'm missing values like 4 because there is a mismatch, right? I'm missing values like 3. So in this case, what is my missing value? I'm missing So id plus 1, so 2, 3, 5, and 6, and this will give us the original selection, right? 1, 2, 4, 5. And here I've got a crucial part here. Okay, so in here, an id should be greater than the max of my id from sequence demo. So what's happening here is max value for your query. Okay, so my original query is going to have 1, 2, 4, and 5. So in this case, not going to have 6, right? So my max value is going to be 5, because in my original query, okay, I'm having 1, 2, 4, and 5, and my max value is 5. So I'm not going to get a sequence more than 5. So adding 1 to each, so I'm getting 2, I've got 3, I've got 5. So if I compare with this, okay, I'll be getting 2, I'll be getting 5, but I'm not getting 3, right? So there is a mismatch. So I don't have 3 here. So therefore, yeah, so I'm getting 2, I've got 3 and 4 in my outer query. And in this case, the 3 is missing, right? So if you just compare this with our originality in our original sequence, based on human readability, you can guess that 3 is missing. And when I add one additional value to each of this original query, which should be 2, 3, and 5, right? And then I can see here that here is my missing value. And because I've got the max of id, it is not going to cross more than 5. So I wouldn't be getting 6. So 5 would be my maximum range. So by this method, you can try to get your missing value. Let's see how this can be implemented in our code. So if you see this, okay, I'm dropping my table if it exists. I'm creating a new table called sequence demo with one column id, and it is going to have integer data type. And then I'm going to insert into this a few values, 1, 2, 4, and 5, 7. So this is my sequence of values that I'm planning to insert into my sequence demo. Let's see how our table looks like. So 1, 2, 4, 5, and 7. Based on our human understanding, what are the missing values? So you're missing 3, you're missing 6, right? All right. So these are my missing values. So this is how you're going to find your missing sequence IDs. So I've already shown you the code demo, and now you can see that 3 and 6 are missing. So that is exactly right. We have got the missing values here based on our code, right? So what has happened here? Okay, let me take this example. So based on our original sequence, these are the values, right? And the max is 7 here. So you're not going to get any value above 7. So based on I'm comparing it with my outer query, right? So if I'm adding 1 to each of this, so this is 3, this is 2, 1 plus 1, 2, 2 plus 1, 3, 4 plus 1 is 5, 5 plus 1 is 6. Forget 6 because that is our max value. And if I compare this with my sequence, so there is 2, okay? So we'll erase out 3. We'll erase out 2, okay? Because there is a match. Okay, and 3, we don't have 3 in our original sequence. And then I've got 5 here. Do I have match? No, so I'm removing 5 here. Do I have 6 here? No, I don't have a match. Because I don't have a match, I'll have this in my outer query. So my outer query is going to compare it with my inner sequence, that is my full sequence of numbers, and then I'm setting the max value. Therefore, our query doesn't go out of the outlier value that we have set, and it is going to give me the missing value. So in this context, you'll be getting 3 and 6, and even with the code implementation, that is what you got, right? So the missing values are 3 and 6 as you see in the below. And so next question, what is pivot? How can you pivot data in SQL? So pivot, why do you use a pivot? Just a sec. Oh, I've got one more example for you as well. So in our next example, if you see, I'm trying to work out this for the dates, okay? So first we saw for the sequence of IDs, and now it is for the dates. I'm running a recursive CT, okay? So how does a recursive CT work? So CT is your common table expression, a temporary table, right? So when I use recursive, it is going to, iterate through a loop again and again. So okay, so recursive means again and again, right? It's going to loop. So it is going to check for my data sequence temporary table again and again. So this is how my CT looks like. So I'm selecting min of log date as date value, fine, from my log data. Okay, that is my table name. And then I'm running an union all. So it's going to add every values together from the above query and the below query, right? And for my below query, what I'm doing is I'm selecting and using a date add function. What does the date add function do? It is going to add a new column with particular date. Okay, so I'm naming it as date val, and then on what basis I'm adding one more date. So I'm setting an interval of 1 day from date sequence, which is my another table, and I'm setting an outlier value as well, outlier, okay, the range value. So my date value should be greater than the max of, sorry, my date value should be lesser than the max of my log date. Okay, so this symbolizes smaller value in comparison to my max of log date. Okay, so I'm trying to run a union, and this is what's happening in our recursive CT. And from this recursive CT, what I'm trying to do, I'm trying to select the date val as missing date. Okay, if you see here, I've given date val here as an alias, right? From my min of log date, I've given an alias date val. So I'm selecting date val as missing date. I've already given an alias, right, as date val. So which is going to be in our date sequence as well. So from date sequence table, so I'm fetching it from my date sequence, and then where date val not in select, not in, so I've run a subquery here, right? Select log date from log data. So simple, right? You're selecting all the log date from your log data, and you're checking if that particular date exists in that. So if it is not in that, you retrieve all the missing values out, I mean the gaps out. Okay, let's see how this works in our code. So I'm creating a table called log data, and this is how our table looks like. So log data with a column named log date, and it is of date time. I'm inserting few values into it, to my log data. The values are 1st of June, 2nd of June, 3rd of June, 5th of June, and 6th of June. So what's the missing value here? It's 4th of June, right? Okay. Now what we are going to do is we are going to generate the dates using our recursive CT. What happens in a recursive CT? You're going to loop again and again, and then by looping, you're going to create all the dates. Okay, so you've got min of the log date, and then you're adding a date with a 1 day interval, and then from this you're going to select only the date val, that is of missing date, from your date sequence. Okay, what's happening here? So you can see that you've already got the missing date. Before that, let's see how our previous table was actually looking like. So this is how our table looks like, right? So by your human eye, you can find that the 4th of June is missing. So because by recursive running, you get to see that yes, your code confirms that the 4 is a missing date. So this is how you check for your missing dates. And so our next question, what is pivot and how can you pivot data in a SQL? So pivot is a way that where you get a better understanding or your better visualization of your table. Okay, for your better understanding, you try to create a pivot table. Okay, so what happens in a pivot table is that you convert the existing rows to columns if that would actually make sense for your data insight. So it's often used for your summary tables. Okay, for example, let's say you have a regional column, but instead now you want to just see sales based on your region. So what you can do, simply you can just pivot it. So by pivoting, you're going to convert all the columns to rows or your rows to columns, vice versa. All right, so you're going to create a pivot table based on sales and which where the sales are going to be aggregated based on a region. It is highly useful for analytics, and with this also you can use case plus group by. So what do I mean by case? So case is where you have conditional statements. Okay, so for example, let's see this code before I show it in the code implementation. I'm selecting region from my table sales. Okay, and then I'm running a case here. So sum is my aggregate function, and in this what I'm trying to tell, case when quarter is equal to q1. Okay, so let's imagine or let's assume, I'll show it in the table, but for now just assume that you have a column called quarter. So quarter is going to be quarter 1, quarter 2, quarter 3, and quarter 4, right? That's how usually the companies work, based on a 3-month window. Then amount. So if it is in the quarter 1, then give the amount. If it is not in the quarter 1, give it as 0. Okay, and I'm using alias as quarter 1, and same for the second case statement as well. So add all the values. So you're going to sum all the values when your quarter is quarter 2, and if it is in the quarter 2, then your amount. So you're going to sum all this amount, and if there is no amount stated, make it else as 0 and then end it, and the alias here is quarter 2. So sales is our table, and this is an important thing, you're grouping it by region. Okay, because you're grouping it by region, you're going to get better data insight by pivoting it. Let's see how our data looks in the actual code implementation. So if you see here, I'm creating a new table called sales. Okay, the sales table is going to have region, quarter, and amount, and region is going to have text type, quarter is of text type, amount is of integer type. I'm inserting few values into sales table. I've run it twice, so let me try to get it out. Let me delete the table. Okay, create table. You could have run truncate, but just to keep things plain. So I'm showing you how my table looks like. So for each region, east, east, west, and west, And for each of their quarter, quarter one, quarter two, quarter one, and quarter two, I've generated values correspondingly as 100, 150, 120, and 130. I'm running to run here an aggregate function which is of sum. So what's happening here is it's grouping by region. So it's going to group by east and west. And then for quarter one, you're summing it up, and for quarter two, you are summing it up. So if I run this, you can clearly see that for both the regions, east and west, for each quarter, for quarter one for east, I've generated 100. Quarter one for west, I've generated 120. Quarter two for east, I've generated 150, and quarter two for 130 for west. But if you actually see our original table, does this look clear? Does this give a better data insight? But if you see after pivoting, you can see that how your data is very well and clear, and it helps us to give a better summary of your data. All right. So jumping to our second session about data modeling. What's the difference between transactional and analytical data modeling? So the key feature of a transactional and analytical databases are the purpose in for the transactional is you're going to run real-time operations, whereas for analytical or the OLAP database, you're going to use it for reporting and analysis. Okay, what do I mean by real-time operation? So any transaction is a real-time process, right? So transaction could be anything. It could be writing a data, it could be updating a data. So it is transaction is going to involve a lot of write functionality, right? So transaction is more of a write heavy workload in general. So an OLTP is going to give us a real-time operation, whereas your OLAP or analytical database is going to be used for reporting and analytics. And because there is no transactions involved, you're going to have a better insight about your data. So it's mainly used for reporting and analytics. And what's the data volume? Because this is transactional, okay, you might have multiple transactions happening simultaneously. But even in that case, it is going to be very small, but the volume could be smaller, but the frequency is higher, right? Because there could be multiple transactions happening simultaneously, right? It's a parallel transaction, so you're going to have a more frequency of transactions happening. But no matter what, a transaction is going to have only a smaller data volume. But in the other case, when you compare it with the analytical, you're going to deal with larger historical data. So it's not transactional, you're going to deal with large historical data. Talking about design, it's highly normalized. Why it is highly normalized? Because it is very write heavy workload, right? So to deal with your write heavy workloads, you need to have your data normalized, which in turn will also help with your data integrity. But for OLAP, you're using a denormalized table. I mean, your data is very denormalized. You can be using star schema, mostly used, or snowflake schema, depending on your business use case. But your data is very denormalized because you don't want to run a lot of joins. You wanted to use it for reporting and analytics. It's for just summary, or you're going to access your historical data and have a look on your data. So it is okay if it is denormalized, but for the transactional data, it is highly normalized. And the examples are most of the write heavy workloads are databases, right? So the examples include MySQL and PostgreSQL. And because OLAP is used for your analytical purpose, so data warehouses most probably come under this use case under analytical platform. So a very common data warehouse could be Redshift, BigQuery, you have Databricks, you have Snowflake. So these are different data warehouses that you have with your OLAP. And for the best practice, a normalization is a principle followed in your OLTP, And denormalization is a step that is usually followed in OLAP because OLTP is write heavy and OLAP is read heavy. So make sure that you have normalized form for your OLTP and denormalized form for your OLAP. And so next question, how would you model a table for user product reviews? So you're modeling a table where you're going to have it for the user product reviews. Okay, so you're going to have a user and he's going to give a product review. So that's what I mean by user product reviews table. So primarily I need three tables because I'm designing an user product and a reviews table. Okay, let me add a line here so that you understand it is one word. So I want a three table primarily, which are users, products, and reviews table. And what's happening here is I'm creating a new table called reviews. And this reviews table is going to have few columns, which we will see on the go. You need a review ID, isn't it? So for each of the reviews, you need a unique ID, which will help us to find those particular reviews. So you need a review ID. It is going to be of integer data type, and this is a primary key as well. So this is the primary key for your reviews table, and the column name is review ID with integer data type. And then you have user ID, and this user ID is going to be from your user table. We will see how I've implemented the foreign key below, but for now just understand that I've got a user ID because and review it's going to be given by a user, right? And this user is going to have an ID, so I want a user ID. And then he's going to review about a product, right? So what product is it? How are you going to find it? So you need a product ID for it. And then you're going to have a review text body where the user is going to write comment about the product, and we can have it in text type. And then you're going to have a rating column with integer as your data type. So you might set a check values or constraint values between like ranges 1 to 5. So in that case, you're going to drop your ratings in integer in that column. And then you can have a column called created at, which is going to store the information in timestamp format. So whenever the user puts in a review, it's going to be stored with the user ID, product ID, the review text, and the rating along with the timestamp. And I want the user ID and product ID to be unique. Why? Because the same user, I want him to have only one review for a particular product. So I am setting an unique key for the user ID and product ID. And then here my foreign keys are user ID and product ID referenced to their corresponding users and products table, because you have to store your users in your separate table, right? And you need your products in your separate product catalog table. So that's your products table. So that's how you create your reviews table. Below are the key points that you must consider. So try to use foreign key for your user and product table, because you need to have a unique comment for each of your products, and each user must have only one review for your product. So try to set that as a foreign key, and then also set it to be unique, because you don't want the user to set multiple different comments for your same product. So therefore set both to be unique. Okay, and then how would you handle soft deletes in a data model? What do I mean by soft delete? So soft delete is where you don't want to actually delete the data. Okay, you don't want to delete actual field, or you don't want to delete the original data. Instead, you're going to add few flags that correspond to the data, saying that it is not in existence or not being currently used. So in simple, the data exists, but it is going to have few flags which is going to suggest that this particular field is inactive. Okay, so that's what is soft delete about. So you're not deleting anything at all, but instead you're going to hold the original data, but you add few flags which is going to symbolize about the activeness of your row. By definition, so instead of deleting records, mark them as deleted using a flag. So flag is something like you create a column and then you can set it based on your boolean values, or you can set it based on a categorical value where you set once you update your data. Then also you can set it using your timestamps. So you can add a column like is deleted. So if your boolean is going to say true, then that means that yes, it is deleted. If the boolean is going to say false, it means that yes, the data is deleted. But is the data really deleted? No, the data is in existence, but it is just giving us a status that it is deleted already, or is it in use. So you can also set it the timestamp for your deleted at column, which is going to show you that from when to when was this particular data in use or in active form. So when you use soft delete, you're going to preserve your history, and in which in turn is going to support for your audit logs. So that's the main purpose of using soft deletes, because you get to have your audit logs, to check the accountability of your data. And then because you're doing just soft delete and you're not deleting a data permanently, you can have easier rollbacks, and it is usually supported in most ORMs, okay, which means that object relational management. So to our third session, the big data tools. What is Apache Airflow and how does it help in data engineering? So Apache Airflow, so this is the icon that you see here. And Apache Airflow is an open source workflow orchestration tool which is used to author, schedule, and monitor your ETL pipelines using Python. So Python is a core language for your Apache Airflow, which you use to orchestrate your workflow. Okay, so basically you schedule your workflow. They use DAX. So DAX mean directed acyclic graph. So directed is you're going to have a direction, and acyclic means you're not going to loop. So there is not going to be interdependency, or there is not going to be any looping functionality between each of this edges, I mean the nodes. So you're going to have a graph that is going to direct what workflow must run succeedingly. So for Airflow, you can use extensible operators that allows you to run multiple tasks of different types. So you can use Bash, you can use SQL, you can use Spark, you can use Python. So you have multiple extensible operators where you get to run it on the each task. So for a DAG, you'll be having nodes. Each nodes correspond to your task, and each edges correspond to your dependency. Okay, the arrow marks. So for each task, you can use extensible operators to define your workflow. Okay, is that a Bash scripting, or you're running a Spark job? So you can use extensible operators to design your DAGs. What is a Delta Lake and how does Delta Lake enhance your data lakes? What is a data lake? So data lake is where you're going to have a structured, semi-structured, and non-structured data. So all these data is going to be dumped in one place. That is a data lake. So what is a delta lake then? How does a delta lake enhance your data lake? So do not confuse with data lake and delta lake. So data lake, you're going to have multiple varieties of data with or without structure or semi-structured. And on top of these, you're going to have a delta table. So delta lake is where you're going to have an ACID compliant storage level layer on top of your data lake. Okay, in simple, What is a data lake? So data lake can be anything. You have S3, you have HDFS. So on top of these data lakes, you're going to set an ACID compliant storage layer. So these are already a storage layer. On top, you're setting an ACID compliance. So delta lakes are built on top of Spark and Parquet. So they are built on top of these Spark and Parquet. And here are the key features of your Delta Lake and how it enhances your data lakes. For your existing data lake, they provide you with ACID transactions, and on top you get to have time travel feature. And because you have a time travel feature, you get to version your data. And because Delta Lake runs in real time, as you see, because it is ACID transaction, so transactions are real time, you can enforce your schema. Also, you can have batch and real time streaming simultaneously. Okay, so both your batch and streaming data can be handled simultaneously. And it also solves small files issue and schema evolution problems. Okay, so what do I mean by small files? So you're going to have multiple small files coming frequently, and Delta Lake helps you to solve this issue and all your schema evolution problem. Why? Because you're going to enforce schema. So because you're enforcing schema, you're going to solve your schema evolution problem. And Delta Lake is one of the most commonly used setup in Databricks and Spark. So therefore, by providing us with these key features, it is going to enhance your data lake. Compare Kafka and Flink in real-time data processing. What is a Kafka and what is a Flink? And based on that, we will try to compare in context of your real-time data processing. Talking about Flink, so Flink is a real-time stream processor. Okay, whereas Kafka is a distributed message broker. In yesterday's series, we saw about Kafka, right? So Kafka produces data, and then it sends your data to your brokers, which are distributed because it works with the partitions. And then the Kafka consumers consume the data from your brokers based on the Kafka topics. So Kafka is a distributed message broker and Flink is a real-time stream processor. So there is a difference. It handles based on pub/sub messaging. What do I mean by pub/sub messaging? So in Kafka, the data is sent to your brokers based on the Kafka topics, and the consumers subscribe to these Kafka topics, and then these messages are sent to those consumers. Whereas Flink works on event processing and analytics. What do I mean by event processing? It works on events based on real-time streaming. So whenever the data flows through in, it processes based on the events. The use cases, Kafka is used as an ingestion layer. As you see here, it's a pub/sub messaging service, or it's a distributed message brokering system. Because of that, it can be used as an ingestion layer. So your data is going to be published from your producer to broker and from broker to your consumer. But in Flink, it's a real-time stream processor. So you're going to perform ETL, you can perform joins, you can use windowing functions in real time. Talking about storage, Kafka is very persistent. But whereas Flink, it can be both stateless and stateful. What do I mean by persistent? So all the data that is generated from the producer can be sent to your broker, and these brokers, it will be stored in your brokers, and these brokers are very persistent. So that's what I mean by durable logs. And in Flink, they can be both stateless and stateful. Okay, so that's all for today's Considering the time, I'll be talking about ETL pipelines and cloud technologies in our next video. So for today, I hope this session was very helpful to you and glad you all enjoyed it. If you really like the video, do like the video. Feel free to share it with your fellow data engineers who are aspiring and trying to ace their interviews. And then if you have any doubts regarding this session, drop it in the comment section. I will follow it up in the next session. And also click the bell button so that you don't miss on our regular updates. We are having plenty of videos coming on your way, so make sure that you're well subscribed and you learn as much as possible. And we have our headquarters in US, United Kingdom, and Hyderabad as well. So do check our website so that you'll get a better insight about our company and what we do. And we also provide you with multiple streams of learning. And on top, the good news is that if you're a regional speaker, we provide you with languages like Data Valley Telugu and Tamil as well. So do check on those channels, and we are giving a new videos daily. So make sure you learn as much as possible. So we are Data Valley, the fastest growing edtech company of 2025, and myself Franklin, with almost 3+ years of experience as a data engineer. So until then, I see you in the next video. This is Franklin, who is signing off. Thank you so much. Hope you all like this video. Good luck with your learning and good luck with your interviews. Thank you so much. Have a nice day.